So this is ELC 131, Circuit Analysis 1, and this video is on alternating current. Now, up to this point in time in this class, we've dealt with only with circuits that are considered to be direct current circuits. Circuits where the voltage is always one polarity and the current always flows in one direction. So we look at an example of a DC circuit, and of course the voltage source is always positive to negative. And when the switch is open, no current flows and no voltage is developed across the resistor. However, when the switch is closed, we'll now have current flow through the resistor, and there'll be a voltage developed across the resistor, a voltage dropped across the resistor that is positive to negative as shown. Now, if the switch is open back up, there's no current, there's no voltage. So in this DC circuit, we can have current, we can have cases where there's not current. But when current flows, when voltage is dropped, the voltage has only one polarity, positive to negative, and the current has only one direction, that's down through the resistor. Now, with alternating current, or as what most of us simply abbreviate as AC, the voltage changes polarity over time, and the current changes direction over time. So we see an example of an AC source, and this AC source is actually a sinusoidal AC source. We'll talk much more about that later. And this AC source is connected to a resistor. And we see from the plot on the right that for a certain period of time, the polarity of the voltage source is positive with respect to the ground. Current will flow in this direction in the circuit, and of course the voltage developed across the resistor will be positive to negative as shown. So that's this period of time right here. Then during another period of time, the polarity of the voltage source changes so that it's negative with respect to ground. And of course, current will now flow in this direction through the resistor, and the voltage developed across the resistor will be positive to negative as shown. So with alternating current, the voltage source, the resultant current, the resultant voltage drop in the circuit changes direction when we talk about current, changes polarity when we talk about the voltage, so that during one period of time, current flows in one direction, during another period of time, current flows in the other direction. So again, up till this point, we've talked only about direct current sources, current that flowed in only one direction, but now we are going to talk about circuits that are alternating current circuits, where the polarity of the voltage changes as a function of time, and the direction of current changes as a function of time. So this is ELC 131, Circuit Analysis 1, and in this video, we continue on with our discussion of alternating current. And in your studies and careers of electricity and electronics, you will encounter many different waveforms or wave shapes. And the one that we see most often, the most commonly observed waveform, is the sine wave. And we see the sine wave illustrated here. And the sine wave, we'll talk about this in much greater detail later, but the sine wave is the waveform that is created when we rotate a conductor through a magnetic field. So the majority of the electricity produced on Earth is produced in the shape of a sine wave. And also the sine wave is the wave shape that's created by many oscillator circuits, and we'll cover these in subsequent classes. And an oscillator is simply an electronic circuit that creates an AC waveform. Now, we'll also see and make use of square waves, triangle waves, sawtooth waves, and waveforms that we can only somewhat classify as being called complex waveforms. So we see illustrations of these waveforms, and hopefully these are somewhat self-explanatory. The square wave goes from 0 volts up to some positive voltage, stays at that positive level, goes to a negative voltage, stays at that negative level, and goes back towards positive. And the triangle waveform is one that linearly changes from 0 volts up to some maximum value, and then from a maximum value to a minimum value, and then of course back towards the maximum value. Now we see sawtooth waveforms quite often, and we generate these through the use of resistive capacitive networks. And the sawtooth waveform actually increases at an exponential rate up to some maximum value, decreases again at an exponential rate, and increases at an exponential rate. And we'll actually see the generation of these waveforms later in this course, ELC 131. And the final waveform or wave shape that I've illustrated here is again referred to as a complex waveform. And this is actually the waveform that is generated when you strike a string on a piano. And we'll talk about these complex waveforms and harmonics and a term called timbre later on in this series of presentations on alternating current. So again, our AC waveforms can take many different shapes. Most common is the sine wave. And then we see square wave, triangle waves, sawtooth waves, and complex waveforms present in electronic and, of course, electrical systems.